21 days. April 2026 turned into a full-scale frontier AI sprint. 4 open-weight trillion-parameter MOE systems released in under a month, each taking a radically different path to the frontier. And they're off! GLM breaks first on the 7th, at 744 billion total parameters, 40 billion active per token, 28.5 trillion pre-training tokens, trained on Huawei Ascend hardware. Slime async reinforcement learning on the backend. 8-hour autonomous execution across hundreds of rounds and thousands of tool calls. Kimi comes up on the 20th. 1 trillion total parameters, 32 billion active, the smallest active count on the track, 15.5 trillion training tokens, the smallest pre-training corpus on the cohort, and Kimi sticks with Muon clip, Moonshot's stability fix that lets Muon optimizers scale to 1 trillion parameters. Here comes DeepSeek on the 24th, and DeepSeek is the largest on every headline axis. 1.6 trillion total parameters, 33 trillion training tokens, 49 billion active per token, 4-bit floating point precision on the mixture of experts' weights, 8-bit precision on everything else, quantization-aware training during pre-training itself. And last out Mimo on the 27th, at 1.02 trillion total parameters, 42 billion active, 27 trillion training tokens, 1 million token context window. And here's the bet, folks, 0 shared experts at trillion scale. Mimo's bet with V2 Flash's techniques carried forward and doubled down. Let's compare these models against one another. First, like knowledge, parameters times tokens. DeepSeek takes the lead on the product, 1.6 trillion times 33 trillion, highest number of parameters n times data or tokens D by a wide margin. Mimo second, at 1.02 trillion times 27 trillion. GRPO third and Kimi fourth on the training corpus alone. Second leg, post-training. This is where reasoning is forged. Active parameters are the ceiling on how much reasoning the model can do in a single forward pass. Mimo takes the lead, 3 full stages, supervised fine-tuning, then domain-specified reinforcement learning across math, safety, code, and agent teachers. Then multi-teacher on-policy distillation, the deepest post-training stack in the cohort, paired with 42 billion active parameters. DeepSeek, a close second, independent SFT plus group relative policy optimization per domain, then on-policy distillation merged with reverse KL. 1 stage shallower than Mimo but operating on 49 billion active parameters, the largest budget in the cohort. GLM third, multitask SFT, then reasoning RL, then agentic RL, then general RL, then on-policy cross-stage distillation, also a deep pipeline but with 40 billion active parameters. Kimi fourth, agentic data synthesis pipeline followed by a joint RL with verifiable rewards plus self-critique and the smallest active budget in the cohort at 32 billion can out-extract DeepSeek's 49 or Mimo's 42. Third leg, context. DeepSeek takes the lead. 1 million token context at 27% of V3.2's attention flops and 10% on the KV cache, by interweaving compressed sparse attention with heavily compressed attention, so CSA plus HCA hybrid attention. Mimo right behind, 1 million token context with a 6-to-1 sliding window to global hybrid, roughly 7 times KV cache reduction, matched on context length, second on efficiency. Kimi third, 256,000 token window, multi-head latent attention, no sparsification, no sliding window, no hybrid layering. GLM fourth, 200,000 token window, the shortest in the field, but GLM uses DeepSeek sparse attention with the Lightning indexer, the same mechanism V3.2 introduced. Fourth leg, deployment economy. Capability per served token. DeepSeek leads, 4-bit floating point precision on the mixture of experts' weights, having expert memory versus FP8 and lowering memory bandwidth pressure on every served token. GLM second, 712 training tokens per active parameter, the highest overtraining ratio in the cohort, but Chinchilla math 35 times the compute optimal point. Mimo third, 3 multi-token prediction layers, the deepest speculative decoding stack in the cohort, roughly tripling output throughput by Xiaomi's own measurement. Kimi fourth, Zero multi-token prediction layers, multi-head latent attention with brain float 16 weights and 4-bit integer quantization. The most expensive serve on the cohort on a per-token basis. The gambles, folks. DeepSeek betting manifold constrained hyperconnections plus 4-bit floating point plus quantization-aware training all land at 1.6 trillion parameters. Muon betting 3-stage post-training and 1 million token context have dropped shared experts entirely. I bet that puts Muon's structure furthest from convention. GLM betting slime async reinforcement learning with a focus for long agentic execution. Kimi betting Muon clip plus the multi-stage agentic post-training pipeline. And here's the call. DeepSeek wins with base model compatibility headroom with pre-training lost tracks parameters times tokens, and DeepSeek leads the cohort on the product, which is 1.6 trillion times 33 trillion. Muon shows the boldest architecture in the cohort with 0 shared experts, the deepest post-training stack at 3 stages, and a working 1 million token context. GRPO takes third on the deepest agentic post-training pipeline with slime async reinforcement learning, enabling long horizon autonomous execution. And Kimi finishes fourth on a parameter times tokens product, with Muon clip remaining the cohort's most distinctive optimizer story. And that wraps our look at 4 frontier sparse MOE systems pushing the open-weight AI frontier, and how each one is trying to push the intelligence further at trillion parameter scale.